Yunong Xiao works on Node.js at Netflix. Yunong, welcome back to Software Engineering Daily.
It's a pleasure to be here, Jeff.
This week of episodes is about JavaScript, and Node.js is one of the most important reasons for why JavaScript is taking off. What is Node.js?
So Node.js is a non-blocking evented I/O runtime that uses JavaScript, and key to its success, obviously, is actually that you can use JavaScript to write non-blocking code, very similar to Java's NIO framework. But again, it's in JavaScript. It's really, really performant because of its usage of the V8 JavaScript engine, which, as most of you know, is what Google uses to power their Chrome browsers, and it is really, really performant.
How much of Netflix runs on Node.js?
So Netflix, as most viewers are probably familiar with, we actually have made a lot of investment in Java as a technology that runs our backend. But recently, within the last year or so, we've decided to transition almost all of our front-end experiences to Node. So this includes, anything from the website to TVs to devices. And we're sort of about halfway through that transition. Our website now runs completely on Node.js, and we're currently working very hard to make sure that devices like smart TVs and other devices like the PlayStation and the rest of the Netflix device ecosystem will soon be running on Node as well.
My understanding is that there are layers that run on Node that are closer to the front end, and then the rest of your architecture is Java mostly. And then there's also these like services that are sort of between the front end and the back end. And then I guess some of these are Node, some of these are Java. Is that accurate?
Yeah, that's a pretty accurate representation. I don't want people to get the idea that we're moving to Node for our backend infrastructure. I think that it will continue to be on Java for a very, very long time, just because we've got a great set of engineers who are experts in that field, and we've made lots of investment in those particular frameworks and software. But at the same time, with the front end services, that we're actually actively transitioning, like I said earlier, to Node, and then we have some sort of, like you said, like in the middle of the pack services. One in particular is called the Asset Packager, which is a packaging service that sends JavaScript and CSS to the front end devices. That will be written, and we're currently rewriting that in Node.
And is there anything special about Java that makes it such that you could not write the services that are written in Java, you could not write them in Node, or is it just like you've got those already written, so there's no reason to really just jump on Node.js and migrate to it?
Right, so there's nothing specific to Java that prevents us from implementing any of these backend services in another language like Node, rather runtime. What's key is that we have a service-oriented architecture approach, so we could write any of our services in any language as long as we speak the common language, which is the common interface, rather, which is HTTP. But we've spent a lot of time and effort to write really, really robust services and architectures in Java, and there's no reason to move off of them now. That is not to say that we won't at some future time, but right now these tools and these frameworks work really, really well for us, and so there's no reason to change.
A key technical element that we should explain is the Node.js event loop. What is the event loop?
So the event loop is a way in which, it's actually been around for a very long time. A lot of user UI frameworks use it, things like X or the macOS 10 user UI frameworks all use the concept of an event loop. And you can think of it as a single-threaded loop where we, as we get events to the loop, we can process them and then dispatch those events as we get them in. So we're only ever processing one event at one time, and that sort of abstracts the notion of having to deal with many of the concurrency issues that come with having to run multi-threaded applications.
And describe this in more detail. So on our Node server, we have an event queue, and then we have an event loop. And one at a time, the event loop takes the event at the head of the event queue and processes the request. And the event loop hands the request off to either the file system or the network or a different process. and each of these other units is responsible for handling the I/O of that request, and then placing the result of the request at the end of the event queue. So it's this continuous process of picking events up off the event queue, putting them on the event loop, and then the event loop dispatches to whatever it needs to be doing. Is this accurate?
Yeah, that's pretty accurate. One thing that I might add is that while you're not, while it might sound like we're running a bunch of things in parallel, the only things that we're running in parallel is the user space code that is invoking, let's say, the file system operations or the networking operations. And with Node specifically, it uses the operating system constructs to be able to dispatch these non-blocking operations out into the operating system and wait for them to come back, whether that's epoll or select or poll, depending on the operating system that you're on. And so really it's the operating system that handles the delegation and the eventing of these asynchronous operating system tasks, like a file system lookup or a network socket.
How do developers scale a Node.js application?
Okay, well, it turns out that that a lot of people hear that Node is single-threaded, right? And so this might make them think it's actually really hard to scale up a Node application. But actually, the concurrent programming model is actually difficult to implement, namely because thread safety and synchronization are hard to get right. And so because Node can distract us with the event loop, where multiple asynchronous processes can occur in isolation, and because the event loop guarantees other processes can be executed in parallel, this means that you're able to write code you're able to write code as if it was just single-threaded. And because Node guarantees that asynchronous operations such as networking or file system access, once dispatched, are executing in parallel by the operating system and won't block the event loop, it's actually really, really easy to write high-performance Node applications because most of the heavy lifting is done by the operating system and the event loop. So you do get the performance of a threaded library, but you get the ease of use of never having to worry about synchronization. Almost never.
We did a great show on Restify recently, and much of the motivation that Netflix had to move to Restify was the fact that you can profile and dive into a Node application with a little more visibility, well, a lot more visibility when you're using Restify. So in general, when you're profiling a Node application, when you're trying to debug something or trying to have some performance increase, what are the aspects of the Node application that you're looking at?
So this is a great question. I think first and foremost, and this is sort of just a general level profiling tip, is that whether it's a Node application or not, the operating system actually gives you a lot of great metrics on your particular process. So you can check memory utilization, you can check CPU utilization, you can check network activity, you can check I/O activity. So those are just great tools that the operating system gives to you for free, right? So that's definitely and that applies to all runtimes, including Node. Specifically with Node you can also get some of these metrics of the Node process itself via the built-in OS module. So you can get metrics again like CPU and heap size. You can also perform CPU profiling if you're concerned about CPU utilization, either using perf events on Linux or dtrace on Solaris or BSD or Mac OS X. And then, of course, if you wanted to profile memory usage, you can take heap dumps of a Node process and a core dump of a Node process to be able to walk the heap for those JavaScript objects to see and to be able to profile your memory.
Do you have any interesting examples of debugging a Node application that happened recently, other than the problem that we discussed in the Restify episode?
Yes, I'm glad you asked that. Actually, I think last week unfortunately we had a memory leak in our Node process, and so generally what we do as part of our deployment process is we'll deploy a canary, which is a very small set of instances and processes that's on the new build, and we run that as part of our production fleet. And so we have the rest of the production instances which are running the old build, and we have a small subset that runs the new build. And we were able to of course we always get metrics like CPU and heap size and RSS, and we could see that our RSS was climbing in the new build. So very obviously we had a memory leak that wasn't in the old build. And so what we were able to do is take a core dump of the new build, the new build in production, and take a core dump of the old build, and we were able to compare the number of objects between the two builds. And it turns out that we had 200,000 node module objects, which is the node. Every time you're requiring a module in Node, the Node internally keeps a module object that's associated with that particular JavaScript file. And we had an issue where we would require a particular file, and that file would throw an exception, but we would catch it and then silently swallow it and just try to require it again. And every time you did that, Node would leak one of these module objects. And so using CoreDOMs and MDB and v8.so, which is a shared object library that ships with Node itself, we were able to actually find these objects and then also find the references that were holding onto these objects and really be able to see exactly where in code this came from and fix the memory leak in this manner. And so look out for a blog post on our tech blog where we're going to go into much of the details about how we actually fix this issue and the tools that we use. But this was one of the big techniques that we use when it comes to profiling and trying to fix issues.
Fantastic. And when that blog post comes out, I will update the show notes with it. So you described the canary process, which refers to a canary in a coal mine where, there's this, history where you can let a canary into a coal mine. If the canary doesn't come out, if the canary just dies, then you know that there's like a gas leak or there's something in the coal mine that's toxic. And this strategy of comparing the old application to the new application, this is iconic of Netflix's strategy of persistent testing against a control group, this ideology of A/B testing, and this is core to how Netflix serves its customers. So, could you discuss how any component of the A/B testing architecture that runs on Node.js that would be interesting to the listeners?
Sure. So, if we want to talk about A/B testing specifically, something that's really, really interesting for us is the sheer scale on which we A/B test. So there could be thousands of A/B tests going on at once, split across multiple different disjoint sets of customer bases, right? And so, as you can imagine, we have one set of web servers that serve the UI for all of these test cases and all of these users. And so this means that our code has to be dynamic enough to be able to generate your unique set of test cases for your user on the fly. And that could change based on the tests that you're in, the tests that you're out of, with the device that you're coming in, the country that you're coming in, and a bunch of other factors. So as such, we've built a bunch of libraries in Node that is able to, one, dynamically generate these API routes. Not these API routes, but the API middleware for your particular A/B test allocation on the fly. And we're also building out a packaging system to be able to dynamically deliver just a specific set of JavaScript and CSS and other assets that's needed to render your particular A/B test, depending on the context of the user.
Yeah, so that's interesting. Let's get back to talking about Node and JavaScript specifically. Describe Callback Hell.
So I'm sure most people have heard of this, but because JavaScript and Node in particular is asynchronous, one of the easiest ways to handle asynchronous functions in JavaScript is to use a callback, right? So you might say you might invoke an asynchronous function and pass to it another function called the callback that once the task is complete, this callback will get invoked. Now, imagine that if you were doing a lot of these asynchronous functions in serial at once, then this means that you necessarily have to nest each function inside the previous function's callback because you want them to run serially, and so the code that comes out of writing JavaScript like this becomes really, really ugly because you're adding multiple levels. For each additional asynchronous request that you make, you're adding another nested level of callbacks inside your previous function. And this gets unwieldy very quickly.
And how does Callback Hell differ on the server versus the client?
I'm not sure that it does. I think on the server in particular, you probably would actually encounter more instances of Callback Hell because on the server, predominantly you are making a lot of asynchronous requests. Right, and performing a lot of asynchronous actions. You might get a request from a customer, which necessitates that you go off and make other requests at databases or APIs or go to the file system or update caches. And you might have to do this across every single request that you get. And so I would imagine that the frequency of the amount of, I would imagine that that you would get more of these situations because by nature, most of the operations that you're performing on the server is asynchronous.
And what are some steps that a developer can take to avoid callback hell, or to fix callback hell once you're in it?
Right. So there's quite a few libraries out there that will very elegantly solve this problem for you. There's a couple that are really, really dominant today. In Node, there's the async module, and there's some other modules that are very similar to async. And what that will do is it changes the interface such that you can pass the async module an array or a list of the functions the asynchronous functions that you want to run. And then the module itself will iterate through these functions and run them for you serially. So you no longer have to nest callbacks within each function. You can now put them inside an array, which is much more clean and clear. The other methodology that I wanted to point out is also something that's more functional called promises. And promises, there are libraries out for promises in ES5 and ES6. In ES6, promises is a native concept, and that's a much more functional way of dealing with callbacks, where the functional nature of the promises lets you explicitly tell it invoke a function, and then, which is an API available to the promise, handle the asynchronous function however you like, and you can chain multiple promises together.
Yeah, actually, I think that's a crucial point. Could you define what a promise is just one more time?
Sure. A promise is a functional way of handling an asynchronous event. So a promise is literally a future, right? A promise is a future which lets you specify, hey, here's an action that I want to do, and I know that it will return at a future point a result. Right. And the nice thing about promises is that you can chain them together. Right. And that's the key aspect of it, is that you can say, here's a promise. It returns a future event. After this event, let's chain another promise onto it and perform some other set of actions based on the previous return values of the first promise.
I'd like to talk about a few more core JavaScript, Node.js application portions. Do you use Browserify at Netflix?
We don't. Well, we do and we don't. This is this is a great question because of the dynamic nature of our packaging system. We would love to use Browserify, but we can't because.
Well, what is Browserify?
Well, to be clear, Browserify lets you use the vast array of NPM modules that's currently existing in the ecosystem, both on the browser as well as on the server. Where traditionally most modules were only available on the server, Browserify will actually make any NPM module available both on the server and on the client. And it does that very cleverly by adapting a lot of the core Node APIs, which are not available on browsers, such as FS or HTTP, and adapting those to work with browser-side constructs.
And to clarify, NPM is Node Package Manager. So, please elaborate a little more on why Netflix can't use Browserify.
So the reason we can't use Browserify when we would love to, either Browserify or Webpack, which is the other competing standard, is because of the dynamic nature of our JavaScript. So if we would like to only ship so traditionally what you would do with Browserify is that you would package up all the necessary dependencies for your app and then send them to the client, right? But for us, that's not possible because we don't want to send you the whole app every time for performance reasons. We only want to send you your exact set of dependencies based on your AB allocation, right? And so we actually have a decision engine that walks your dependency closure, figures out the set of packages that you need based on the inputs of the system, which is your browser information, your AB allocation, your member information, and a bunch of other context about a specific customer. And then we generate a set of packages to serve back to the client. And so we do leverage a lot of the core libraries that Browserify has that's part of the Browserify pack module, but we've also had to write our own dynamic packaging system built on top. So you could say that we kind of run a hybrid. We use a lot of the key technologies first developed by Browserify, but we've sort of forked it to leverage the dynamic nature of our A/B tests.
Fascinating. What about socket.io? What is socket.io?
So socket.io, if memory serves, is a bidirectional communication channel, and you can run that on top of HTTP or WebSockets, and it allows you to do full duplex communication between the server and the client. So it's very similar to WebSockets or HTTP2 with server-side events. It lets you do bidirectional communication in addition to the traditional request response you get it with HTTP 1.1. So now the server can send you events without you actually having to request for them. And this is really helpful, this concept, because now you can get pushes from the server. So maybe you can get a push to invalidate caches on the client side instead of you having to poll the server all the time. And this greatly increases the performance and optimizes optimizes our request. It would optimize your request volume.
There's an interplay between what is rendered client side and what is rendered server side. Is Node.js changing what we decide to render on each side?
Yes, most definitely. Node, because it's in JavaScript, or rather the server-side code is also in JavaScript, you can now have the liberty, if you write your code a certain way, or use a packaging system like Browserify, where the code that you run on the server can be exactly the same code that you run on the client. And so you can now dynamically decide which part of the page to render on the server and which part of the page to render on the client. And this is sort of a lever, a dial that you can tune based on your performance expectations. But this lets you write just one set of JavaScript, and then that can render on both the client and the server.
Which aspects of the JavaScript world and the Node.js world are changing the most rapidly?
So with Node, I think the API is still changing rather quickly, and this is a good thing because it's great that we can still innovate until we get things right, because Node is still pretty nascent. The Node Foundation is something else that's also growing. It's reassuring to see the enthusiasm that it's generating, in particular to the number of new working groups that it's created and the amount of new contributors that the foundation has brought in. In terms of JavaScript, I think the language spec itself is changing quite rapidly. ES6 has now become finalized, and there are the TC39 community, the TC39 committee is working on ES7 with a bunch of new features as well. So the language itself is actually changing quite rapidly. Also, the ecosystem of JavaScript is getting quite rich. We're getting lots and lots of new modules in JavaScript every day, and this means that if you needed to work on a project and you needed some set of dependencies, most likely those dependencies have already been written for you and be shipped as part of NPM. We're also blurring the lines, like we talked earlier, between client and server via the sort of isomorphic JavaScript concept.
Yeah, ES6 is something I haven't had a chance to cover in JavaScript Week. I would love if you could define what ES6 is and how it relates to JavaScript.
So ES6 stands for ECMAScript 6, and ECMAScript is the ECMAScript standard, right? It's a pretty significant update to the language. And it's been, I think, probably 4 or 5 years since ES5 was standardized. And it comes with a bunch of new features. Of course, I'm not an expert on ES6 or 7 or on TC39, but I think some of the great features that come are things like constants with lets, promises as a native object. You actually now get sort of object-oriented style type extensions. So you can literally do class foo extends bar instead of having to do prototypical inheritance. But it comes with a lot of also syntactic sugar to make your JavaScript a lot clearer and simpler as well. But I'm only scratching the surface. I would recommend that listeners go and check out all of the new ES6 features that are out there. And then in ES7, there's also a lot of great proposals. One of them that Netflix has been driving in particular forward is RxJS and something called observables. So reactive programming, again, I am not the expert here, but reactive programming lets us perform a lot of asynchronous tasks and do them within coding a much more elegant fashion.
So maybe this is something you won't have a great answer to, but I'll ask you anyway. Do you have any idea how do you simply augment a spec like ES6? How do you just add classes to it and just not impact performance negatively?
Well, I think that those are sort of somewhat orthogonal. The features of the language is different than sort of the runtime considerations, I think. Because JavaScript is still, at least with Node and on V8, it's still compiled. It's just compiled at runtime. And so really it's about adopting the new language spec and then presumably updating the JavaScript engine, which in this case is V8, to have the same performance characteristics when it comes time to compile the JavaScript as in the old format in ES5.
Yeah, it's interesting. I mean, I would tend to agree with you that they do seem like orthogonal considerations. I guess I'm not a language expert. It just does sound like if you introduce this completely other class model, we've had prototypes for a long time, and you're introducing classes. It seems like there would be some sort of, I don't know, inefficiency that would add just in terms of a no free lunch sort of world. But maybe that's incorrect.
Everything is compiled eventually back down, right? So
right.
I mean, I think, and again, both of us are. I'm certainly not an expert in V8 and the compilation engine there, but I would imagine that objects, whether you declare them in the prototype style or whether you're using classes, ultimately gets compiled down to the same types of objects.
Right. Okay. So, delving into more areas where neither of us are complete experts, would you say that JavaScript is the new bytecode?
I do think that JavaScript has become ubiquitous. It's available now both on the client, on the server. It's gaining lots of steam, particularly on the server. It's been sort of the language that's used on the client side for decades now, but specifically on the server, it's really gaining a lot of steam. And so I think when you say bytecode, you're really referring to the portability of it, and especially with frameworks like Browserify or Webpack, JavaScript now can run on the client, on the server, and with Node or the browser run on multiple operating systems. So, we have JavaScript now that can run on devices. Like, I forget the name of there's a startup that gives you a board that uses NPM and JavaScript as the language to talk to devices. The name escapes me, but it's being used everywhere. There's like robot.js, which lets you fly, robots and drones around in the air with JavaScript. Of course, we're using JavaScript to serve assets both on the server and on the client. Lots of companies use JavaScript only on the backend as Node with Node.js. And so I really think that, like you said, it has really become ubiquitous in the tech world.
Yeah, and what you said about robots.js. I've been hearing JavaScript is big in the Internet of Things, and I haven't really done a show on that either. So I'm not sure. Do you know any more details about Internet of Things meets JavaScript?
Yeah, I'm just trying to think about. I forget the name of that particular. Was there a particular company that develops these little Raspberry Pi-like systems on chips that where the interface to talk to native hardware devices is all in JavaScript.
Well, we'll put it in the show notes.
Yeah, but anyway, I do think that especially now, JavaScript is definitely becoming part of the Internet of Things. I mean, a lot of companies will actually write all of their apps, whether that's on a client, on a browser, on a smart device, on a TV, all in JavaScript, and really use JavaScript as a way to share large code bases amongst different architectures and clients.
So I have kind of an ambitious question. Let's say Netflix was starting over today. There was no Java, and that you decided to make the application completely JavaScript. Maybe this is an unfair question, but would there be anything that you would do? Like, would you reorganize the architecture in terms of how, we mentioned at the beginning of this conversation that in Netflix, you got this notion of back-end Java services and then front-end JavaScript Node.js stuff, and then stuff that sits somewhere in between the two that are JavaScript Node.js stuff. How would you re-architect things so that it was all JavaScript?
Well, so first, big disclaimer, these opinions are my own and don't necessarily reflect those of Netflix and Netflix engineering. In my past, before I went to work at Netflix, I worked at Joint, where we did exactly that. We built our entire technology stack on top of Node, right? So that meant back-end services, front-end services, and everything in between. And so I think because of the way that the Netflix engineering stack is set up, it wouldn't be trivial, but it would require a lot of work to re-implement all of these libraries in JavaScript. But because of the fact that we have a service-oriented approach, it wouldn't be impossible or difficult which is to say that we still require a lot of work, but it's not impossible to be able to convert all of our existing Java services into JavaScript. But of course, we're all about using the right tools for the job, and where Node excels is handling lots of asynchronous events and sort of blurring the lines between the client and the browser, but it doesn't do very well when it comes to compute-intensive tasks. So for those specific types of tasks, Java or some other, even C or C++ would be much better suited frameworks. But definitely where JavaScript and Node has its advantages, we would definitely, if we were to re-architect the world again, use Node in those places.
I just talked to a engineer from Spotify, and he said that Spotify's architecture is very similar to Netflix's in that you have this backend that's kind of defining your streaming operations, and you can build whatever front end on top of it you want. But really, the core secret sauce power of the application is this backend streaming. You get streaming right, you can pretty much do whatever you want on top of it. And so my understanding is that, like you said, like Java is really good for these backend high performance and in this case streaming operations. So if you wanted to do that sort of streaming stuff on Node, do you have any idea what are the types of operations that Node would choke on?
I think Node is actually really, really great at streams. If the Streams API, which is still a work in progress in Node, I think will become one that's really great and really easy to use and very performant. Streaming really just operates on uses operating system level constructs. And so whether you're in JavaScript or Java, it doesn't really matter as long as you can hook into the operating system constructs. So I think that streaming bytes across the wire is something that Node is very, very good at because it largely just gets out of the way and lets the operating system handle the tasks. I think the reason that most folks don't use JavaScript or Node for these types of tasks, which, to be clear, we did at Joyent, right? And I'm sure a lot of other companies do this as well, where when they have Node as their sort of their backend stack, but it's just that there hasn't been a lot of use cases out there where people have documented, hey, we are actually using JavaScript in these sort of high throughput tasks, right? Like I said earlier, where Node really struggles because of its event loop and its single-threaded model is for really high-intensive CPU-intensive tasks. So we probably wouldn't want to use Node to do sort of digital image processing or anything like that, but definitely for streaming bytes across the pipe or handling large numbers of connections when it comes to web servers. Those are things that Node.js is really great at.
As I understand, Netflix uses pretty much the core Node, the same version of Node that's open source. Do you know if there would be any reason for a company to use its own version of Node with some sort of fork, some sort of different Node version?
I would imagine that, I would hope that companies that do fork Node and make contributions to Node for their own purposes would contribute that back into the mainline, right? Because that's being good open source citizens. And I know that this isn't the case in the JVM world, where lots of companies do fork their own versions of the JVM. Most of the time, they do this to get visibility into the particular runtime, and they don't contribute back to the open source community. So I would hope that companies that do this do contribute their work back to the open source community. And we do run just a stock implementation of Node that we get from Node.js.org. And we're sort of actually working with a V8 team. We have a patch out for V8 that will greatly make it much easier to profile Node's CPU usage on Linux. And so we're actively working with the V8 team to see if we can upstream this particular patch that we've made to Node. Really, it's V8, not Node. I should take that back.
Got it. What is the open source ecosystem of Node like? You described it some there. It sounds like the best practices are really nice. People aggressively will, if they do a fork, they'll commit it back to the original source. But give me an idea of what the open source ecosystem's like.
I think it's great. I think it's really open. Node was born in the era of GitHub and Git and social coding. So pretty much most of the modules, when engineers out there are writing new modules, they write it with the ideology that it's going to be open source, right? And I think that is really great. And so having npm, which is the node package manager, and if you're just looking at npm, you'll see that there are probably hundreds or millions of packages, hundreds of thousands or millions of packages out there today. And so the open source ecosystem is full of enthusiasm and full of great contributors, and there are probably modules that can do everything under the sun, right? And so that's great. That's incredibly awesome. And I think, so this is sort of the userland modules. In terms of the Node core team, especially with the foundation, with the new Node.js foundation, they're really picking up steam there as well and making more contributions to the Node core.
I've been researching the Hadoop open source ecosystem for next week, which is Big Data Week. And one thing I found is that the Hadoop open source ecosystem is largely contributed to by Cloudera. Is there a similar large player in the Node world where you've got just a lot of the work being done by one small group, or is it much more decentralized?
I think it's much more decentralized, especially when it comes to the userland modules. So if you were to go on npm and just look at the sheer number of authors that have created modules, I think you find a very, very large group of folks. When it comes to the Node core team, that is the team that's responsible for the Node.js runtime and libuv, I think there are still a handful of, so more 5 to 10 companies that make lots of contributions to the Node core. So companies like Joyent and StrongLoop and NodeSource in particular, and a bunch of other folks on the Node foundation, they really do invest heavily into Node core, which I also think is great, because it's good to get multiple companies involved in the core infrastructure of Node, because that means that we're not blinded by a particular one company's interest, but are sort of working towards a greater good of the community.
If people want to get involved with open source, a project like Node, what's the best way that they can start?
I would say just get a GitHub account and get involved, either by writing a new Node module that doesn't exist, or by just starting to use Node or any other open source framework. And as you find bugs, you can file issues at least, so that the maintainers know about them. And even better, you can file a pull request and try to make fixes for a particular framework. But those are sort of really, really easy steps to get started with open source. And as you start to interact more with those contributors and maintainers, you start to form relationships. Maybe you'll start hanging out in some IRC channels. But that is really how you want to get started.
Great. Well, Yunong Xiao, thank you for coming back onto Software Engineering Daily. It's been a real pleasure talking to you once again.
Thank you for having me, Jeff.